Alright, so we're trying to find the inverse of these problems, and before we do that, let's go over some steps here. Nathan, step number 1.
Replace f of x with y.
I would write that in my formula sheet for the next quiz or test. Melissa, number 2.
Interchange x and y.
What's another word for interchange? Switch x and y. Thank you, Melissa. Alonzo, number 3.
Solve the resulting equation for y.
Solve for y. Get y by itself. Kayla, step number 4.
Change x plus y to f of -1x.
Change y to the inverse of f. Okay. Sebastian, what did you hear? Tell me what's right. Okay. Now what? Remember, it sounds silly, but circle it, arrows. Alright, Sebastian, what do we got? Or tell me what should the next line look like? You're switching the x's and y's, right? I want to point this out to you because this will be super helpful second semester when we're doing the trig problems. Okay? When you're doing the switching, it's like an on and off switch. To show that you did the switch, you're going to actually put the inverse here. At -1. Thanks, Sebastian. Cindy, what do we do next? Divide by 6. What do I got, Cindy? One 6. I like that. Equals y. Ellie, are we all done? Where did I go? Annalie, yeah. Everyone say inverse of f.
Inverse of f.
Don't say f -1 anymore, guys. Annalie, how do you say that? Equals what? 1/6x. And that's our answer. Raise your hand if you got that. So that was a linear, right? So the next example is another linear. Let's go ahead and try that one. Who's on? Alex. What should we do over here? So tell me what to write. So instead of f of x, what am I writing? Yep, cubed. I have a practical thing is when the problem's starting to get very big, you can draw a line down your equal sign. Jocelyn? Tell me what to write. I'm sorry. Say that again. There it is. Jocelyn, what should we do next? So yesterday, hopefully I showed you the PEMDAS chart. Here we're solving for y. Solving, you're going in this direction. It sounds silly, but a lot of students would do crazy stuff like divide by 4 or take the cube root at this time. So you said subtract 3. What's left? You can stop there. Thank you. Fabio?
Divide by 4 on the right side.
What do we got?
X minus 3 over 4 equals y cubed.
I'm not going to do anything about separating the fraction. There's kind of like no purpose to do that. Sometimes we like to keep them together. Fabio, keep going. So we did adding and subtracting, multiplication, division. Okay, so you're going to put a radical sign. But in this radical sign, what's this number here, Fabio? So they call this the cube root. What is it called, Cos? You must put that 3 there. If you didn't know, if I just say the square root of 16, what's the invisible number here? It's actually a 2. So in math, there's always these invisible numbers you need to put on your math classes and recognize. Are they like zeros? Are they ones? Or in this case, that would be a 2. This one's very explicit. It's a 3. The exponent and the cube root will cancel, and you're left with y equals all of that. And the last thing we need to do, class, is just change the y to be what? Inverse of x. We like to put the y or the x equals or whatever it is on the left side and your equation on the right side. Make sure that all of that is inside the radical sign, and that would be our answer. So I think that was our first time doing a inverse problem with either a power of 2 or a power of 3. And last one. Brian, what's the first thing we're going to do? Tell me what's right. Brian, instead of writing f of x, what are you writing? So y equals... Yeah. Jonathan. What do we do next? Yeah, you're Jonathan. Oh, we have 2? Jonathan H. Tell me what's right. Raisin. You said subtract what? She says subtract 1. Thumbs up, thumbs down? That's correct. Temptation pi would have been divided by -3. Raisin, what's left? Notice how if you put -1 over here and then plus x would not be wrong, but variables first are better. Yave? Alright, what do we got? 1 over 3x? Yeah, but look at this. This is the -1/3, correct? What's this one? +1/3. If you guys need an in-between step, it's x over -3 plus a negative 1 over negative 3. Does that make sense? And then all we have to do is make sure it says the inverse. And that's our answer. Three examples, two linears. Polynomial is another example of taking the inverse.